Hi there, this is Chuck. Time to make another quick video. I've usually been working on my Black Hat pinball machine, but the Wizard of Oz machine that I own has been acting up lately, so I thought it was time to fix it. I've got the fish board out right now. The last lead in the chain, the number 7, is dead. The allegro chip is fried, and this machine has been nothing but problems. It's one of the original run machines with the 5-volt lighting system, and basically the allegro chips die on these things all the time. And as you can see on this machine, all of the single RGB LED boards that are red are ones that I have designed and used to replace the stock green ones. So on this machine, basically I'm up to 12 of the replacement single RGB LED GI boards, and I've also replaced the final LED in the chain on that board, the No Place Like Home board, and also this board here, which is, I think it's got the Tin Man LEDs on it. I don't remember, I think it was one of the hurry up LEDs. It's the last LED in the chain, but it seems to be a common problem that the last LED's the one that burns out. So the boards that I've designed, like this one here, you can't see it on this side, but it's basically got an output buffer, and there's a bunch of TVS's, and basically a lot of input and output power and signal filtering on these boards to just try and keep them alive. And up here on these boards, which are the multi-LED boards, I've got my own power conditioning board, which you can see here. Here's the fish board, and you can see that last allegro chip is toast. So we've got to sub that one out. And here I'm just pasting up my output filter board. I thought I'd just give a quick overview of this stupid WOZ design. At least the original one's kind of dumb. I'm not sure how that engineer even got a job. But overall, I don't like the Slam Jersey Jack because their machine is really fun. But it is a super fun game, and I would suggest anybody that's buying one, probably get something with the version 2 lighting system, or be really handy. Anyway. All right, I'm back for more. Here's the little buffer board that's built up. It's got +5 in the middle, and then there's input and output. So this just sits on the end of the multi-GI boards. And that's basically all there is to it. The input comes in on the left, and the power is in that middle connector. It comes down through the PTC fuse. There's that big diode, is a Zener diode there that clamps any voltage spikes to 5 volts. 100 microfarad cap, smooth out the supply. The QFN is a buffer, and then there's a PVS sitting on top of that. It goes to the output. So not really much to this, but I think the idea is it just keeps any power transients from going back down the signal wires into the final allegro chip on the multi-GI boards. And this right here is my test setup. So I've got an Arduino that pumps out that allegro protocol. And for this setup, I took this wire, hooked it into this the filter board, and then the output went into this the original Jersey Jack GI board. And you can see this is pretty lame because it's just the allegro chip on this board, and the input goes to the chip, and then the output and like no filtering, nothing. And there's the RGB LED that it drives, whereas this is the replacement board that I designed, and you can see there's a shit ton more going on here. So if we spin it around this way, so again, that's the input on the left, and this one, the input goes through TVS's and a bunch of filter caps before it hits the Allegro chip, and then the output goes through that same buffer chip, and then again through the TVS. And it's also got the PTC resettable fuse, where the Jersey Jack just has like a real fuse that gets blown quite often, which is annoying. And again, a nice big cap, and that D1, another big TVS for the power. So these boards that I built, they're a little more robust than the Jersey Jack ones for sure. And anyway, I'm pretty sure after maybe another 3 more years, I won't have any original Jersey Jack boards left. Back again here. Just going to replace this Allegro chip on this fish board. And the reason I'm making this video is this just came out of the machine, and man, this is disgusting. It's like, I guess that's what happens to pinball machines. And you know, this is just in my house. I'd hate to see if this was on site and what, I don't know, some operator-based machine would look like. This is just sick. Well, I don't have a cameraman, so you're not getting this in real time, but I just used my soldery workstation to pull off this little Allegro chip off the fish board here. So now it's time to clean up those pads, tin it with some lead solder, and throw a new chip on. Hope it works. Now, there's the fish board with the Allegro chip removed and the pads kind of cleaned up. Got a bunch of solder flux on there now just to put the paste on. I'll paste up a new Allegro chip and I'll hit it with the hot air tool. So this here is my dirty little secret for repairing WOZ boards. I knew when the first one went that there was going to be an issue, so I bought, I don't know, 120 of these things. These are called shift right boards, and these are the donor boards for the Allegro chip, and that's where I get mine from, because they're pretty much unobtainium right now. Okay, the Allegro chip is on. Let's see if this thing can focus. Anyway, it's not perfect, but it looks like all the pads are connected. And I'll just clean up that solder flux, but we've had a casualty on this side. The connector is not the same shape, which is not surprising since we've hit it with heat from underneath there. So I guess the first thing to do is I'll hook the fish board up to my test jig over here and make sure that the LEDs work, and that maybe I'll have to change the connector too. Make sure that the output works. All right, there's the fish board in the test harness. Comes from the Arduino, goes to the single RGB LED board, and then into the fish board. So that's the yellow brick road basically is what the fish displays. And this LED right here, that's the Allegro chip that I replaced the LED. It was funny colored. I'm hoping just replacing the chip will bring the colors back to normal. And so that seems to work. That's good news. Now I've got to test the output of that Allegro chip, so I've got to replace the connector now, and then I'll put the fish board, hook it up to the Arduino, and put this single LED on the output of the fish, just to make sure that both the input and the output work on that Allegro chip. And once I'm satisfied with that, then I'll put the output buffer board on the fish and put it back in the machine. Here's the fish board ready to be wired up with the output buffer board. This is the worst part of this whole project, is making these stupid wiring harnesses. I use Cat 5, and the big problem is I don't have a proper crimper for these little pins, so I end up having to do that with needle nose pliers, which is a real pain in the ass, especially since there's 10 of them to do. Time for another update. I just finished building this tedious little cable, and I'm in the process of replacing the connector on the fish board. I kind of mangled that a little bit, but that should be okay. And I'm also 3D printing a little holder for that buffer board. So hopefully that makes things a bit more insulated and better looking, rather than just boards hanging off in midair like some of my previous attempts. Here's the test setup where all systems go. We've got the fish board is working, and it's driving the single RGB LED. And 1 second here, I'll just disconnect this. Okay, I'm back. So I had to build up this power connector to feed the fish board. And here's what the fish board looks like now. So I've replaced that top connector, and I've got my 3D printed buffer board holder stuck on the fish board with 3M VHB, the very high bond strength. This stuff is great. And so the power to that buffer board is, you know, just the standard Jersey Jack connector, but I've got it soldered onto the back of the main power connector on the fish board. That part's a little kludgy, but it's still modular. So yeah, looks like it all works, and I'll be back when it's mounted. Okay, there's the fish board. It's mounted in the machine more or less. It's not screwed down tight yet, but it looks not too bad. And let's fire it up. Okay, here we go. The moment of truth. Well, there we go. This seems to work, and that's 7. That's the Allegro chip that's been replaced, and from what I can tell so far, the color looks more towards normal. Or maybe it doesn't. I'm wondering if that's a different batch of Allegro chips or something. This is supposed to be all white, and this chip is blue, and also there's no place like home, and that is the last chip in that string. That's also kind of blue. Maybe that has something to do with the buffer board. I can't really see why, but that's, I don't know, it's a little odd. But to me it looks better than it did before, that's for sure. And over here is this blinding total light. That one's on its way out. It seems like if there's any light at all in that RGB LED, it's always full brightness. So let's see here. Yeah, any color, it doesn't matter. It's just way too bright. That's going to take some investigation. I'm a little unclear why that light and that light have that bluish tinge. Anyway, at least it's working. That's step one. Okay, I took the buffer board out of the chain. That's still bluish, so it's not the buffer board. It's either got to be something stupid like the batch of Allegro chips, or maybe the lead just got toasted from the Allegro chip dying. It was one of these hurry lights that were the last lead in the Tin Man board, and it looks perfectly fine. So I don't know, I guess my money's on bad lead.